I'm McCord from CyCore Systems. We are a consultancy in a lot of areas, but including voice over IP, based in the States, but we do work all over. We've been building Kubernetes-based voice infrastructure for roughly 5 years, a little over 5 years. We've been doing voice systems in general since we were founded in 2004. And personally, I have been doing voice systems since about these days with the old voice modems, if anyone is old enough. So Kubernetes, just a general audience survey. Do you know what Kubernetes is? Show of hands. Okay, I don't need to do any of the introductions to Kubernetes, I think. In general, I can just say it's a way to deploy applications generally, specifically container-based applications in a way that is highly programmatic and easily automatable. But big problem with Kubernetes is that it's built for web-based formats. And voice, doesn't really fit very well with that. But with a few cheats or some clever tools, we can actually get Kubernetes to work pretty well with voice systems. But to take a step back, let's look at what some of these difficulties are. So the first thing to get into Kubernetes is that you have to have your application inside a container. So the idea of a container is a static, reusable image that has sufficient flexibility to be placed anywhere. One of the big stumbling blocks for voice systems is that they are notoriously complicated in their various aspects, one of those being compile time options. And since containers are image-based deployable components designed to be static, building in the flexibility you need for that base image is often a bit of a difficulty. And the final thing that a container needs is to have standard interfaces by which it can communicate with the rest of the system. So configuration is the other big factor that, that voice systems by most implementations are just painfully complicated. You have dozens of files, if not more. You have directory structures. You have mixing of static data with configuration data, with runtime environments, with scripts, all combined into one big mess of configuration. You have a huge problem with networking. This is one of the biggest variations between web-based technologies and voice technologies. You have things that need to know their external IP addresses. They don't tolerate firewalling and NATing very well. You have asymmetric UDP. You have huge swaths of open ports that need to be arranged. Stateful routing for stateless protocols. Weird unused DNS records like NAPTRs that nobody has ever heard of and most APIs don't even support. And you need rapid and reactive intrusion mitigation. Storage is another huge area of difficulty. By and large, when you're deploying a voice application on a regular server, you don't really care too much about the various classifications of storage. But in Kubernetes, the storage classifications are quite important. You need to separate your static data files that are large from your semi-static data that is maybe only updated once and persistent throughout time, or your highly volatile data that may need to run on a RAM disk if necessary. The database needs of a voice application, particularly on the media side, can be quite demanding. And finally, Kubernetes, if nothing else, embraces change. Anything in the Kubernetes environment can change at any time. An IP address, a node can go up and down and be rebooted out from underneath any application, and everything must be designed to handle and react to these changes. Most voice software, not so much. So that brings us somewhat to the concept of the operator. Now, according to the CoreOS operator SDK, the first SDK out there for Kubernetes operators, an operator is a method for packaging, deploying, and managing a Kubernetes application. Now, that kind of says something, but it doesn't really say what it is. So I modified that slightly to say an operator is software. A Kubernetes operator is software which packages, deploys, and manages the Kubernetes application over time. So no difference here. Our operator is a piece of software that works with the Kubernetes API to, over time, deploy and manage a specific application. In our case here, we're talking about the Kamailio operator, which we declare in a very simple YAML file or JSON file, if you prefer, just like every other resource in Kubernetes. Key to this deployment is its declarative nature. Everything that is needed to run Kamailio as a registrar is presented in a single YAML file. Everything else is a black box that works in concert with the other pieces. So to take a look at this, we'll break this down just a little bit. We have the first two lines here that are API version and kind. These are the declarations of what is going to follow. It's basically the namespace of the API and the type of thing that we're defining. In this case, both of these are somewhat arbitrarily named, but that they are registered as names in Kubernetes is important. So we call our entity in the Kamailio operator the proxy set. It is a set of proxies that we are defining by this configuration file. Then we give it an arbitrary name, which defines the name in the cluster for that proxy set. And then we get to the actual specification. So the first thing we have in here is the size. We're telling it to start off with a size of 3. This means that the operator will generate and maintain, over time, 3 Kamailio instances at all times in the cluster, however it can schedule whatever resources are available. It will make 3 occur as best it can. Next, we declare the cloud platform on which we're running. The operator that we build supports a number of cloud platforms, including, in this case, DigitalOcean, AWS, GCP, Azure, and also, of course, bare metal, in which case you just leave cloud blank. It will make a best effort that, in general, will work. Host network. For edge proxies, it is generally easiest to use host-based networking. Modern container networking implementations, CNI plugins, allow you to use real public IPs inside your cluster much more easily, but it's still simpler to just use host networking on the edge. This allows you to have a nice border defined and have all of your other components on the inside use the Kubernetes networking. The profile template and the custom template. These are kind of the more interesting components. As part of the configuration management, we have developed a Kubernetes-specific templating library, which allows us to plug directly into the APIs of Kubernetes from a handlebars or mustache. Technically, it's a Golang templating system. But for those of you who've been in web technologies and are familiar with JavaScript, handlebars, mustache, it's very similar templating, very simple templating technology, but highly pluggable. So in our case, we have a number of the most common APIs from the Kubernetes service plugged directly into the templates. Not only that, but as we have a profile template and custom template, under the hood here, we actually have a 3-layer configuration system. We have the first layer, which is the core, which configures Kamailio at the bare minimum of requirement. And that is to give us RPC access to update the configs and to bind to a port on that RPC system. All of that is static and defined, but everything else is open. Then we have the second layer, which is the optional layer of a profile. This is intended to be a best practices module for a certain function. In this case, it's the registrar profile. So it implements in library form the most common elements of a registrar at which you can plug your own custom code with any of the route points and add on to the module configs at any moment. So it gives you a baseline to start from with a registrar. Now you may want to, many of your current deployments are not going to run just a registrar. You frequently will run a registrar and you'll have an LCR and maybe bundle all of this in to one Kamailio instance. In Kubernetes, this is a contraindication. Instead of bundling things together, we want to break things apart as much as possible. Because in Kubernetes, you can run any number of pods across your resources, it's vastly easier to manage them if they do a smaller set of actual items. So in this example, we want to run a registrar and just a registrar. If we want to run a session border controller, we want to just run a session border controller, and so forth. Then we get the custom template, which is where you modify the profile if one exists, or overwrite any of the files or build your own. It is, if you want to plug in exactly your current Kamailio config, you can do so. Just hit the interface points that we define in kamconfig, which we can discuss later as time permits or interest has. But the idea is you can leverage or not the Kubernetes API very easily from your configurations using the templating system. Finally, as an example, we have dispatcher sets. So one of the problems with Kamailio in its general form in the route script is that in order to update it, you have to restart Kamailio. So for highly dynamic pieces of the system, such as dispatchers, if you are using them to talk to, say, your internal media gateways, that may change several times a minute, we don't want to have to be restarting Kamailio all of these points. So we've broken out several of these to use the RPC to make update calls without having to restart all of Kamailio in it. So the dispatcher sets are one of those. All of this is fine in the YAML file, but obviously something has to work underneath the hood. So the operator itself is fairly simple. It's just a loop that checks that everything that is described in the YAML file is the way that it's supposed to be. If not, it makes it so. And in order to do that, it builds off of various tools we've built over the years. So while the operator is brand new, built for this talk in particular, all of the tools are time-tested over 5 years of development and deployment of real-life systems in the wild. And included in these are the Kamailio config engine, which I spent a lot of time just previously talking about the templating and API hookups, the dispatchers module, which, by the way, is going to be updated very rapidly now that I found out about 5.2's distinct memory updates on the dispatchers module. Thank you. There's a semaphore service provided. Essentially, this is because you have to restart Kamailio on every config update. You don't want every Kamailio to be restarting at the same time. So we have a semaphore system used by camconfig, which obtains a lock and then only allows a single Kamailio instance to reboot restart at any given time. We have a number of different IP address updaters and DNS updaters for your edge nodes. So in this way, even though you may have a dynamic IP assigned to whatever node it's running on, you can update the DNS records as needed to have them point to the right places at any given time. Likewise, if you have public IPs that you can bind, you can call the APIs if the cloud provider offers them and assign the IPs to the nodes as present. And of course, profiles, as we talked about before. Now, of course, you don't have just Kamailio in most voice deployments. So we also have in the works a number of tools for other implementations in the voice systems architecture fleet, including RTP engine, which, by the way, automatically compiles the kernel module on whatever system it is, importing and installing that module. The Asterisk has an entire set of tools very similar in place. And FreeSwitch is not as fleshed out yet, but it will definitely get there. All of the tools we've built are open source, released under the Apache 2 public license. And you can find a small collection of them here, quite a number of others in our namespace. And that is pretty much it. I'm open to any questions.
Okay, so we still have time for question, and then we break for lunch. Anyone with a question? My question is, I mean, always this looks nice and, you know, on slides and so on, but the thing is, like, also I have experienced this with kind of replication. When things kind of break for whatsoever reason, it would be easy to recover. I don't know, the orchestrator or some config. What are the elements that you can get to over such unexpected events, but they can
So
happen?
one of the nice things about Kubernetes in general, if you use the components that Kubernetes already has in place, is that you have a rudimentary revision control. You have, as long as you have your config managed in some way, and in this case, we manage it in config maps in this example, which isn't the best for revision control. But I mean, all the time, you always need some way to manage your configuration. This doesn't solve that problem. But what it does do is give you static images from which all of your applications run that you can very easily roll back from.
With regards to the operator, you said that the operator in its loop will go through and check to see if the configuration of the box is correct, and if not, fix it. How does it decide whether the configuration is correct? Is it downloading the config and doing a diff, or?
No, it takes a hash.
So it is taking a hash of the configs and checksumming everything.
Yeah. So we could do it just by the reference. So you can, and we do actually have a number of watchers for config maps and secrets, so that if we get an update from the API saying that it has changed, we check it. But if we do just that, we get a lot of changes that we don't actually want to restart Kamailio for. So the camconfig engine has a number of internal checks that registers each resource that it's monitoring by its templating, and also registers the such things as the config map, the source of the templates. It takes a hash of the config map reference, the key reference, and also keeps track of all of the resources that are updated. So it compares those two and says whether or not it needs to restart Kamailio as a result.
Okay, so probably we should break. Okay, last question, quick one, and then we break for coffee.
Hello. I would like to know more about DNS updates. For example, when a container starts and it boots the Kamailio instance, you are getting an event from the Kubernetes and make an API call to update SRV?
Yeah, so how this works is when it's actually somewhat difficult because Kubernetes does not provide you a reliable way of knowing what the external IP address of a node is. So built into the pod in which Kamailio is deployed is this network reporter container. And what that does is discover, either through the cloud APIs or through its own NetDiscover engine, what the external IP address is of that Kamailio instance, and then reports that back to the operator, which incorporates that as an annotation on the Kamailio pod, which records the public IP v4, the public IP v6 if available, and the public host name. Those will all be recorded as annotations on the pod. If there is one of the supported DNS or IP address updaters, it will have been watching for updates to the annotation. When it gets the API, the update from the API server that has changed or been added, then it will process all of those pods and update the IP addresses or DNS records as required.
Okay, so I got a request for the very last question.
Thank you. Very small. Does your toolset support only for Unix systems, or you support Windows platform too?
I don't have a Windows thing to do anything with, and I have not deployed on Windows in 15 at least years. So I have no idea.
He doesn't have a Windows at the office for that reason.
I fired all my Windows customers 15 years ago, and I never want to see them again.
Shen, many thanks. Many thanks.